Our next speaker is Elad Inbar, and he's going to talk to us about the Robot App Store. Take it away, Elad.
Thank you, Wayne. So, hello everyone. Can you hear me? I can hardly hear myself because this stuff here. So, I'm the founder of Robot App Store and Robot Lab, which I'll talk about in a second. This little guy here is now, and I'll talk about him a little bit more in a few minutes. So just to give you a little bit of background, I'm Israeli. I started this company in Israel and decided to move to the Bay Area around the end of 2011. The reason I decided to make this move and basically move the company, myself, my family, and everyone, is that most of the robotics industry in Israel is around homeland security, defense, and other military uses. And this is where the government money goes to, all the grants to the universities and everything. So all the students that graduate are actually, very, very talented in all these kind of aspects. In my point of view, I think that the personal robotics and the entertainment robotics has a huge potential that we're just starting to see this revolution happening in front of our eyes. So this is why I moved myself into this area, because we have, like your class, very vibrant community here around robotics, computer science in general. And you may ask why Robot App Store? We see amazing platforms here, and for many years this was the state of the robotics, that people worked on their projects, created amazing things, stair climbing and bipedals and so on. But it stayed at that level. It never matured to a commercial product. And in the past, I would say 4 or 5 years, we see a trend that many companies looking into this space, into the personal and educational and entertainment robotics, and starting to deliver products products that you can actually buy. You can either program it or download software for that. You are not going to modify it because it has a lot of sensors and everything, and I'll explain a little bit about it in a few minutes. But just as it is out of the box, it's really capable. So it really removes all this hassle and building your own platform, your own robot. And seeing this trend happening over and over again, and we can see, I'm trying to categorize the robotics industry, and we have all the way from the smart robots all the way to the dumb robots. And in the middle, we have what we call the smartphone robots, that they harvest their computing power from smartphones, tablets, and so on. And we just keep seeing more and more of these products being shipped to the market. I would say it's a pace of something like once a week or every other week, which is pretty amazing if you think about it. And we are in contact with many vendors, many manufacturers, and we just keep seeing this happening over and over again. So the way that it's if I'm trying to look at the trend and where we are going to, is that we'll get our platforms and we'll basically go somewhere to find software that will help or do whatever we want. So for example, folding laundry, and have Melanie here with unloading the dishwasher. We had a discussion about that, and this kind of application that we all want at the end of the day. We might want to upgrade the application that we already got on our robot, but the platform is so capable, and why not just keep upgrading it and keep adding more and more functionality. So the same robot that can unload the dishwasher can play chess with you and physically play, not just the software. Or can fold the laundry and take out the dogs or whatever. We saw some of that using the PR2 robots in the past 2 years, I would say. And there are other projects, and you can go online and search now, for example, and they're going to demonstrate it. And basically, that's the trend. This is why I created the Robot App Store. Another, let's call it another division in our activity is something that's called the Robots Lab, where we actually take robots and bring them to the classrooms and try to engage students with math and science and basically demonstrate all kinds of abstract concepts using robots to these students, and I'll show that in a few minutes. So first, let's talk about this one. So this little guy, let me turn it on in the meantime. So this little guy is basically a computer. It's running Intel Atom 1.6 gigahertz, pretty powerful, not most powerful that you can get, but pretty powerful for everything that we need. It's running in the head. It's a full computer with Wi-Fi, Bluetooth, infrared, 2 HD cameras, 4 microphones, and it's really capable. I mean, it can detect its environment using either ultrasonic sensors, or there is another modified version of the head with a laser rangefinder, including gyro, accelerometer, and even all the way down. We had this discussion with the bipedal earlier, all the way down to force sensors resistor, so we can tell what's the pressure on each side of the leg as we walk. And the manufacturer is a French company called Brew Robotics. And they actually created a library which is called Naoqi, N-A-O-Q-I. And this library is basically open source. So I mean, everyone can add, modify, even replace it if you want, and do whatever you want with that. You can program this robot using everything from Java, C++, .NET, and even ROS. So it's really up to you what you want to do and where you want to take it. And as a connected computer, basically, because it has Wi-Fi, so it's connected to the internet, you can do whatever you want, right? You can offload computing to another computer, over the network, or you can consume all kinds of web services and these kind of things that actually make it very, very interactive and very updated or up-to-date with the data, with the information. So we don't need to teach this robot everything. The robot can basically take, harvest information from the network and apply. Right out of the box, without any special software skills, and if you want, I can show you that in a few minutes. We can basically create all kinds of interactions like face detection, face recognition, text-to-speech, speech-to-text, object detection, and so on. Friendly. As a computer, right? It needs time to boot up. So, just going back, so right out of the box, you can create whatever you want. I mean, a whole set of interactions just by dragging and dropping all kinds of behaviors to the workspace, just like we program Lego NXT, for example. Can I get the other microphone? Can I get the other microphone? No, I want the... Wait, okay, sorry. No, I want for the robot. So, it's pretty loud here, so you probably won't be able to detect my voice, my command, so I'll just do that, using the...
It is something else.
Is it on?
Presentation. Sure, let's talk about me. There is so much to say. Okay, I will try to give you a quick summary.
I'm using this one.
Hello, my name is Now. I'm a humanoid robot imagined and manufactured by Elad Inbar Robotics. I come with the software and I'm fully programmable. I'm autonomous and I can connect to the internet through Wi-Fi. I can recognize your face, answer your questions, that play music, grab objects, and even play soccer like a pro. I've more than 1,500 brothers and youths all around the world in universities and research laboratories.
Now, to create this behavior, this demonstration that you just saw, this presentation, is something like, I would exaggerate, 10 minutes.
What do you want me to do?
He's trying to ask for other things. So let's see some other capabilities.
Connect to your account. I am going to check this. I just need a few seconds. There is a lot of people on the internet today.
This is an email
You
demonstration.
have received an email. I am going to read it. Peter says to you, long time no see. Would love to catch up. Call me soon. Do you want to reply to this email?
Yes.
I'm
Yes.
listening to you.
That's great. We'll connect later on.
I repeat your message.
That's great. We'll connect later on. So the robot can basically record or read our emails, record the response, and send it back as attachment to the
I
sender.
sent it back.
One of the
Your message has been sent.
now one of the things that people are doing with this kind of robots is trying to help old people to communicate in the 21st century. Because for us, open a window and click on a button is very simple. But think about old people. For them to open a window is to actually open a window. They don't understand where we live. And if we get this kind of robot in front of an old person without any experience in technology, they can basically interact with just the way that we interact with human beings, just talking to them. And the robot can detect whatever they want. So it's pretty nice and easy. Let me show you some.
You can ask something.
Dance.
Okay, let me concentrate. I just need a few seconds. After that, you will be amazed.
What do you want to see? IG, Michael Jackson.
I am listening to your choice.
Michael Jackson.
Thriller. You know, I really like Michael Jackson.
Appreciate it. So let it rest a little bit.
Another one?
Now, I'm working with this robot for like 3.5 years,
I'm
and
going to rest.
going to rest. And I saw over the years, whenever we introduced these robots to the classroom, we saw the excitement and the engagement the students has. Whenever you just bring this kind of tool into the classroom, they're all like, "Whoa, what is that? I want to work with it. I want to play with it. I want to control it. I want to program it." And one of the things that we kind of missed with this kind of robotics classrooms is that all these amazing tools are, let's say, focused on robotics or computer science or mechatronics or these kind of things. And we kind of forgot the basics, where the algebra, the geometry, trigonometry, even the basic physics, like, gravity and so on. And students really struggle to understand the basics. Students that already can work with robotics are, pretty well, they're doing well, and I'm not worried about their scores and everything. But I guess you all heard that, especially the parents, maybe to the older kids, when you introduce quadratic equations, right? And second question is, why the hell do I need it? I mean, I'll never use it in my life. And I mean, the young people really find it, challenging to understand why. Why do I need that, and what shall we do with it? So I want to show you. That's the second part of this talk. It's a product that we call Robots Lab Box. Now that's just need this go right here. This here. So what we have here is basically a box full of robots that we deliver to classrooms, to schools. And in this box we actually, provide tools to teachers, to the educators. I don't know if you can see from there. I'll try to raise it a bit. So with this box, we actually deliver a tablet to the educators, and I'll connect it to the projector in a second. And we basically control, thank you very much. We control all kinds of robots that are in it. So for example, and this is one of the lessons that I'll demonstrate. I guess you're all familiar with this one, right? The air drone. Using the air drone, we are demonstrating all kinds of abstract concepts, as I said, like quadratic equations. For example, one of the lessons that we have here, and let me connect and show you that. It will be better. No, it's okay. I think it's okay. It's not long enough, so I'll have to stand here. That's it. No, I'm not going to quite. Okay. So this is basically the interface that the teachers show to the students. And what we're doing here is basically we're teaching the students the relationship, as I described earlier, between the height of the quadcopter and the area that its bottom camera can capture. So the higher the quadcopter, the larger the area, right? This is something pretty straightforward. Now, since we're talking about algebra teachers, we don't assume that they have any experience with robotics or computer science or anything that is even close to that. And this is why we created a very nice and intuitive interface. So for them, and I'm not going to fly it right now, but for them, the only thing that they need to do is basically slide their finger on this slider, and as they do that, quadcopter will take off. And you can see on the right side, okay, we get the data from the sensors of the quadcopter. It has an ultrasonic sensor at the bottom. And basically using this data, we can show the students the relationship between the height of the quadcopter and the area that this bottom camera can capture. Of course, it's not connected now, so we don't have live video stream, but basically they can see that. Now, this is something that is totally revolutionary when you think about teaching algebra, because robots can be so cool, and we all know that, and students and everyone really love them. But when we try to bridge that into the abstract concept, we have a big gap. And what we're doing here is basically we're bringing the concrete world of the students, their physical universe that they can see and feel and touch, into the algebra classroom in this case. Now, they can see that, they can understand that, but as teachers, we're probably interested in seeing the parabola behind it. So this is where they can see the relationship between the height and the area. And this is where they can actually see that it's not a linear line, it's a parabola. Okay, and this is where we can actually teach them why the left side, for example, is grayed out, because if this is the height, we can fly negative height, right? So it makes sense to the parabola, it makes sense to quadratic equations. And after we are done with that, we want to reinforce the learning. So what we do is we basically let the students calculate themselves all the data points. For example, what if we cannot see here, it's only half. But for example, what if the height is that? What should be the area? Or if the area is that, how high the quadcopter should be? Students work on the equations on the right side, okay, come up with their answer. Whenever they're ready, the teacher hit the play button, quadcopter takes off, and they can actually see the result, the outcome of their quadratic equation in real life. So it's not like, yeah, sure, run that, they have -2 plus 2, whatever, and it's fine, and no one really understands why it's there. So this is just one example, and as I mentioned earlier, we created a whole set, this is for the teacher, we created a whole set of lessons. In each one of the topics we have a long list of lessons that covering a whole, whole concept or a wide type of information that the teachers actually need. For example, I mean, everything is, you probably know that as parents, I mean, everything is aligned to the common core standards these days. So everything is aligned with that. That's one of the important things for the teacher. So another thing that we have here, I don't know if you saw this guy. Someone see it? It's a company from California called Brew Robotics. They created that. Using this one, we actually teach all kinds of conversions, for example, from angular velocity to linear velocity. Okay, frame of reference. For example, we have one motor rotating on one side and the other one the same speed, just the opposite side. The frame of reference, I mean, the actual movement is 0. And sometimes students really struggle to understand this kind of concepts, but when they see that, it's really helping them. The same with distances conversion between angular, the radius to the distance, to the actual distance on the ground. Another thing that we have is another robot that you're probably familiar with, Sphere. You familiar with that? Yeah. So everything here is basically controlled from the tablet. With this one, what we do is we basically put it on a mat on the floor, just like the FLL mat, the Lego competition, and we project a virtual reality grid on top of that. So the teachers can basically teach the students all kinds of, again, abstract concepts like slope. What's the slope? Why do we need that? So for example, if we need to take the robot from where it is to hit a monster somewhere on this virtual grid, then we need to actually calculate the slope. So we have a grid, X and Y, and the students need to calculate 2 points, where the monster is, where the robot is, and what's the actual linear equation that will take the robot from where it is to hit the monster. So we're trying to basically bring this experience into the classroom, but using robots. And the last tool that we have, just a second, is a robotic arm, which we created because we couldn't find any commercial product that can do that. And using this robot, we basically teach all kinds of geometry, trigonometry, polar coordinates, and these kind of things. So for example, if you think about robotic arm, it's basically a triangle, right? So if we need to pick up something from here, for example, okay, we can calculate what's the distance of this edge of this triangle, and if we calculate the distance, we can calculate the sine, the cosine, depending on the lesson. And this actually brings to life the basics of algebra and geometry and so on. And we launched it like a month and a half ago at a conference in Texas, and we've got amazing feedback from educators. It's like we worked with 14 teachers in creating this product, and we tested it in classrooms and everything, but when we introduced it to educators, I mean, they are all like, wow, where have you been? I mean, I needed that when I was a student because it would help me understand some of these abstract concepts. And this is really I believe, I mean, this is really something that is really important, which, I call it demystify, the robotics world. Many people just tend to think about robots as the Terminator, right? That's what Hollywood sold us for so many years. But they can do a lot of things, a great service, especially in education. And if we think about it and just connect it back to where we started, these are all apps that controlling robots. This is, again, the robot app store. It's all the same. So if you own, a quadcopter, for example, you can, as a parent, you can just download that and run it on your tablet and help your child to understand this kind of, robotic questions, for example. So that's basically, I think, within my limits. And if you have any questions, I'll be happy to answer.
Okay, everybody. Nobody can hear the questions. I'm going to carry the microphone around for people to ask questions. So raise your hand if you want to do a question. Okay? Okay. So, we're going to go back here.
So what does it cost to have one of these boxes in a classroom?
It costs $3,500. Not that much.
Is that now different from the $16,000 one?
Yeah, now it's 16,000. Okay, the box with everything, including the curriculum, including the lessons and everything, is 3,500. 3,500 without now. Now is not part of that. Okay, so we're talking about these 4 robots. I mean, the quadcopter, Spheron, the mustache guy robot, and the robotic arm. Any other question? Yeah.
How much does that cost?
Now, this one's $16,000.
Oh.
By the way, there is, we're working closely with the manufacturer. We're actually representing the manufacturer of Brew Robotics here in the US. And there are plans to cut the price to somewhere around $5,000 in a time frame of a year. We just got a huge investment from a Japanese company, SoftBank, if you're familiar with that. And something like $100 million, and they're starting to build the production line. Right now it's handmade in Paris. So that's part of the cost. Someone has to pay for that.
So you talked about the classes that you've taken it into, the classes that you've taken it into. Have you done any quantitative research on it yet with the classrooms? Any kind of classes that don't have it versus that in terms of science and STEM capture?
That's a great. That's it. One, two. That's a great question. We didn't do any quantitative comparison because we need to run it for a year and compare 2 classes that run it through everything. But what we're doing is within this tablet, basically within the lesson, the teacher gets a quiz that is aligned with everything that we are teaching them per lesson. And what we did is we basically deliver the quiz to the classroom that saw the demonstration using the robot, and to another classroom which didn't see that. And we saw huge differences. I mean, huge. It's not scientifically approved yet.
No, but you did a quality experimental kind of study.
That's
So
right.
did you do any qualitative kind of capture with the students and the teacher at all?
Not yet. But it's in process. I mean, we just launched it like a month and a half ago. And actually, we've got purchase orders from schools from all around the country, which is amazing. I didn't expect it to come so soon.
Another question? Okay. Thank you very much.